All right, everybody. So, Pesto is going to be giving a talk about AI security, no hype, just hacks. He's going to be talking about AI, where it is in your organization, and who and how it's being used. I'm going to keep it brief.
Yeah, you bet. Appreciate that. Thank you very much. Thank you everyone for coming. It's so good to see you. I am super excited to be here. I'm going to briefly introduce myself, and then we'll kind of go over, a high-level agenda, what we're going to talk today. But thanks to, UTA, and thanks so much to BSides for putting this on. And again, thanks for everybody sitting. I appreciate you coming to see me. Did that work? It did. So a little bit about me. A lot of folks I've seen around here probably got started in the same way I did, which was back in the IRC in the mid to late 90s. I was extremely fortunate. I met a lot of good friends who called themselves Ninja Networks, and I learned a lot from them. Maybe familiar to name some of the more senior DEF CON heads here. They were big back in 20 years ago or something. They did a lot of real cool stuff at DEF CON. If you're ever interested in that stuff, head to ninjas.org and check it out. There's some pretty cool stuff. And I've been a professional information security guy ever since. Started on firewalls, did a lot of Linux and Unix security, lockdowns, things like that. I made a change about 10 years ago and switched to doing security analytics for insider threat hunting. About maybe 6 or 7 years ago, I did a BSides talk on ethics in insider threat monitoring. About, 4 or 5 years ago, I went back to school. I got a degree in analytics, and I started learning about AI and pivoted then to AI security. So I've been doing AI security for about 4 years now, since about around 2020. So I think you'll find a lot of people going forward. I suspect there's going to be two different groups. There's going to be groups that have an AI background that are getting into security in this space, and then there's going to be people like me who came from a more traditional information security, well, I guess not traditional anymore. Now traditional is probably you get a degree or whatever, but come from a information security space getting into AI. So that's kind of where I'm at. I love talking to BSides. It's my 30-year background. I talked about ethics. I did a talk a few years ago on AI security, and this is my third one. So really happy to be here. My son's a student here at UTA. He might be in the audience now, but I'm not going to point him out and embarrass him because we have a Q&A section, and he might get revenge. So. All right. So my inspiration for this talk was recently, in the past couple of years, there have been a lot of AI security classes. And I thought, finally, I've been doing this on my own, reading white papers, doing it the hard way. I'm going to take some of these great classes that are out there. And I took one from what's my quote here? A well-known security certification organization, right? I took one from Udemy, and I've taken a couple from some vendors, and they are the worst classes I've ever taken. They are really bad. They do not teach you anything. It's like they all read the same top 3 Google results and just made 2-day classes and workshops out of it. So I challenged myself to do a high-level and real-world AI security talk that if any of you, go to these classes, you can at least, kind of be armed or have a good foundation to sniff out some of the garbage they're slinging. And there's stuff you can do in your network or organization, just starting today. So we'll start out talking about threat modeling, and we'll do a high-level threat model for AI. We'll talk about how AI threat modeling is different from traditional threat modeling. And then we're going to take a break and take some time to refresh and reflect. And during this time, I don't want to turn this whole talk into a vendetta against a certain large and well-known security certification organization charging $1,500 for a class and getting a fundamental question completely incorrect. But I do want everyone here to be aware of a common misunderstanding regarding a particularly thorny problem concerning AI. I'm going to leave it a mystery for now. I'm going to reveal it a little bit later. It'll only take a couple of minutes, and it'll provide a good segue to our next section, give our brains a little exercise, have a little fun. And then we'll wrap it up by talking about some of the tools and techniques that we can use to test, that means attack, AI, and mitigate some of the risks that we've identified in our threat model. We do have a Q&A portion at the end, but feel free, just jump in anytime. You don't have to raise your hand, just yell at me. You're not being rude. We got to use that time, whether we use it in the middle or at the end, it doesn't matter to me. So just jump on in if you have any comments or questions. All right. All right, we're going to do a warm-up little threat model before we start talking about AI. I'm sure many of you are familiar with this. If any of you were at the talk on threat modeling earlier, we're going to try to cover some little different aspects of it so we're not rehashing stuff. But so here is an exact diagram of how everything on the internet works. Not really, it's just a very bare bones, high-level diagram. But I think maybe most of the important bits are here, or at least, enough for our conversation. We're going to spend just a couple of minutes doing a quick threat model for a make-believe application. We've got, a web or an app server here, connected to the internet, connected to a database on the back end, or it's reading and writing, and then, users are coming in from the internet to the front end. So a threat model, if you haven't heard of one, is a tool that we use to understand what security requirements are needed for a project, for an application, for an organization, really for anything. In our case, we're just going to pretend that we're turning up a new app and we want to do a threat model. So we draw a diagram, a very crappy one in my case. I'm legitimately bad at drawing diagrams. It is not a necessary skill for threat modeling. Don't let that deter you. Just go in. Brendan this morning talked about he's seen threat models on the back of napkins. It's absolutely true. You can do it anywhere. It doesn't matter. Once we got a diagram, we're going to start adding threats like right on top of the diagram. We're just going to brainstorm and think of things, right? And we're just going to stick them right on the diagram. We're not going to do that here. I've got 3 because you guys are going to be way too good at it. So looking at these threats, right? Once we've got the threats all down, we assign mitigations to each one, right? So that we can correctly evaluate the risk. It's worth noting, kind of historically, we used to demarcate, lines of zones of trust, untrust, semi-trust, red, yellow, green, whatever you call them, rails. Since zero trust, came in, this may be effective for your organization or it may not. I don't really do it anymore, but I drew an example just in case. We demarcated zones of trust here, so we have the red indicating the internet. I don't know if you can tell, but there's orange on the back there to show that basically this is saying we don't trust anything past the red, and in front of the orange is a little bit shady. And then back here where the database is, we kind of want that green zone, if that makes sense. So we've got the diagram. We got all the zones. We're going to stop and talk about Stride for just a second, right? Stride is a method that we can use to do threat modeling. It was developed by Microsoft in the 90s. It was maybe the only good thing developed by Microsoft in the 90s, I don't know. But you can read the acronym there on the side. The idea is that all the threats that we're going to identify in our threat model is going to fit into one of these categories on the right. It's going to be a spoofing, tampering, repudiation, information disclosure, denial of service, or escalation of privilege. You write the threats as they come to you, and then you kind of fit them into here. You don't really take the spoofing and say spoofing here, spoofing here, spoofing. You can do whatever you want, but I don't think that would be very effective. You just basically think of how we can attack this, and then you kind of list it in that stride. You can do a table or a list or however. All right, so I've got a threat actor over here. If you couldn't tell, that's a threat actor. That's what I look like when I'm at work. And for the purposes of this talk, we're going to just pick like 3 threats. And we're going to imagine, this is what I do when I threat model, that either I don't know what mitigations are already in place, or I just pretend it has no mitigations in place. So there's a chicken and the egg thing here. Be like, oh, well, you can deny a service, but you already know your network, whether you have big honking routers there, or if you have a SaaS provider to protect you from DOS. I still throw it on there, and then I list those mitigations at the last step. Your mileage may vary. All right, the first one we're going to start with, we got a tampering threat here on the database from a SQL injection attack, a classic, a good old-fashioned SQL injection attack, right? So we're going to pop that right there on our threat model again. If you don't have a diagram, you can just literally just write it or whatever. We got a DOS on the front end. You never know what's going on there. And for good measure, all right, we're going to throw an information disclosure threat from someone sniffing unencrypted traffic, unencrypted requests. 3 pretty simple models are threats. There's, of course, a lot more, but I'm not going to go into the details of threat modeling. That's just kind of an example of what we do. Now that we've enumerated the threats, right, we need to look at what mitigations are either in place or what mitigations we can kind of bring to the table in order to kind of lower the risk of some of these threats actually being realized. A very thorough threat model will help you determine, like I said, those security requirements that you're going to need. So for example, to mitigate this information disclosure threat, you can require that you use TLS or MTLS, some kind of encryption standard to mitigate that threat. Once you've got that mitigated, right, it doesn't go away, but the risk from it kind of is lower at that point because you can list that as a mitigation. There's other mitigations that you can choose, but that's just an example. Now, a high-level threat model, right, is going to be better for informing basically the risk management process, and the amount of detail that you're going to go into, it just depends on things like the sensitivity of the data, the visibility of the project, how much resources you have. But in my experience, for big projects, we kind of do it high level. And if you're having something like where you're turning up an app, you would probably go into a little bit more detail, but honestly differs from whatever your needs are for that threat model. All right, so now we know what threat model is. We know how it's used. Let's talk about our AI threat model. Now, we're just going to focus on threats to the model. So big disclaimer here. We're not going to focus on the environment that you need to build in order to support your model. And it's not because it's not important, it's just because that's more what we just talked about. All that stuff still exists when you deploy AI. That threat model doesn't go away. The stuff we're going to talk about now is the stuff you have to do in addition, just for the care and feeding to protect the model itself. In a full development, you have RAG databases, right? You have a whole MLOps pipeline, but we're just going to pretend that that's already taken care of. Sorry. All right, so what kind of attacks do we have against AI models? These diagrams, now there's two, are from NIST. This to me is absolutely amazing. I'm not saying it's the most confusing, most confusing diagram in history. There have been others, right? But we're not going to talk about that. We're not going to go into all of these threats in detail either. There are just too many of them. But we will talk about mitigations that we can use to manage the risk from all of these attacks later. We're just going to kind of cherry pick a few of these attacks that are kind of representative of the rest, at least from a mitigation standpoint. So I think you'll still get a pretty good idea, even though we can't go into each one in detail. So on the left, this is a diagram I'm actually pretty familiar with, right? This is a taxonomy. It says of attacks on predictive AI systems, right? It calls them predictive. You'll also hear the term discriminative. What that means is you're not talking about GenAI. You're not talking about a generative AI. The generative AI or GenAI is on the right. Usually when most of us hear AI, we think about now the stuff that's here on the right. Okay, we think of ChatGPT, we think of Midjourney, we think of whatever they're using to make music, I don't know. But anytime you're creating something new text, new art, new music, that's a generative model. And those are on the right. On the left here are the predictive AI systems. So we don't hear as much about these days, but they're super important. This is like computer vision for your car, right? When you do that, you don't create anything new, but you still really want to be able to tell a stop sign from like a speed limit 55 mile per hour sign. That's categorization. It's done by prediction. So a predictive model isn't wrong. It's basically predicting that that's going to be a stop sign. So it's not wrong, but just a different term, discriminative, whatever. All right, that out of the way. Let's take a quick look at a diagram. Hopefully it'll come up. There it is, look at that. Again, exactly how AI is deployed. This is a bad, but hopefully sufficient AI model diagram. Note the training data on the bottom left, okay? Training data is used to create the model. It doesn't really connect to it. Your model doesn't really reach out to the training data every time someone queries or anything. That would just be a database pool. But it is important to our threat model, so I kind of just put an arrow there to remind people that training data is going to come into play in our threat model, but it's not actually live on the network. I know it's a bit confusing, but we need it in our diagram, and it's a good reminder of that special relationship between the training data and the model. Now for our demonstration, we're going to keep it dead simple, just like we did with our web app. We'll have users connecting from the internet to query the model. Again, it's not what real architecture looks like. I've extracted the most important bits, I think, for easier presentation, but everything we talk about will still apply everything we do in the threat model, it's still going to apply no matter how complicated your MLOps delivery is. It doesn't matter. I just kind of, scaled it down for the talk so I didn't have to talk about every little piece. All right, we got a threat actor? We do. Here he's back. And we're going to start a threat model. All right, so first we're going to add an evasion attack to the model. An evasion attack allows the attacker to submit specially crafted input, right, in order to get a desired output. You can think of this, one example is if you were using a model to predict whether someone's credit score, is good enough to give them a credit card, for example, right? You can understand that if I had terrible credit but still wanted a credit card, it would be beneficial. I could benefit, right, from tricking the model into giving me an approval, even though I don't really merit one, perhaps. That's an example of an evasion attack. So you're manipulating expected input into what's called an adversarial input. That's what the hack is. That's where where you would put the buffer overflow if this was, C code or whatever. That's the adversarial input, right? The model can be tricked into giving basically incorrect output, and there are tools that we're going to talk about later that can help you create adversarial input or adversarial examples so that you can try it out with models that you can download, off the net. What else? There are tools. Okay, yeah. So for evasion, some of these attacks are white box attacks. Right, you actually need access, like an elevated access to the model. You can't just be like, well, I'm gonna go, take down Google Photos, with an evasion attack, unless you had some kind of elevated access. Now, that sounds like, well, I don't need to worry about that, but there's an important caveat. It's not a showstopper, and I'm gonna tell you why later. One more thing. All of the OMG, ChatGPT said something it shouldn't have said. Those are all evasion attacks too. Those are a special one. They call them prompt injection attacks. There's a couple other names. I call them prompt injection, but those are also examples of evasion attacks. You're putting in special input to get a certain answer back. All right, let's look at an example of an evasion attack. Do I have one? Oh yeah, this is one in the wild. This is years ago. This doesn't work. Don't worry. They fixed it, right? But this is somebody shined lights. You can see that person on the right. They shined little white lights on the road, making it turn. It looks like a lane is turning, and of course the car can't tell the difference between light and paint. It looks just like the road is turning. And just for a second, it starts veering, toward the trees there. So this is a perfect example of an evasion attack. This is a perfect example of why traditional information security is not gonna work for AI, right? There are certain models that no matter how many firewalls you have, no matter what SDLC you have, it's not going to fix a guy shining a light on the road, right? So that's why we need to take special care when we're deploying AI models, especially, obviously, big important ones like self-driving cars. Okay, GenAI and classification models are especially vulnerable to evasion. Not every model is. A lot of more simple predictive models, you don't have to worry too much about evasion and robustness, but anytime that you're doing classification or generation, you'll want to make sure that you put that in your threat model. All right, we'll talk a little about model extraction. Model extraction, super important, okay? It's an attack. This attack only requires basically that I can query your model. I need to query it a lot, right? But I don't need any kind of elevated privileges to your model or anything like that. I can just, be a normal user. The attacker basically queries your model so many times and stores the output in his own training data, right? He uses output from the target model to train his own model. Now, this can be done, believe it or not, if with enough access and enough time and resources to where it effectively duplicates the model. You get the exact or close enough by several decimal points result from the target model. You've stolen the model, right? You didn't have to go in and download anything. You didn't have to hack an account and all that stuff. You just queried the model and then you have basically copied it. Now, the thing about this is, yeah, it sucks. This guy stole my model. He didn't pay for it. He can go use that model and stuff. But there's another thing. Remember when I said that you needed like special privileges? You needed that white box to use to make adversarial input. if you have an exact copy of the target model, you can now use your own model to build that adversarial input to the target model. And you can do it, you can, at your own leisure, basically perfect it as much as you want because you've got your own model, your own copy of the model. So model extraction is super important, like I said, for a lot of reasons. One is just they're stealing your model, which is a crummy thing to do. Two, they can be used to create the adversarial examples that we talked about earlier. All right, what happens if we're training our model based on model inputs by users? Some of you probably know this, things like, the one that always comes to mind is spam detection, right? You click spam, not spam, and it trains a model. And they've always used models for this, Bayesian models, ever since, Dawn Eternal, I don't know, but for a long time. But now it's done with more, these days, sometimes with more sophisticated AI. And there we have a threat from a data poisoning attack, right? So supervised training, you have supervised and unsupervised training methods when you build an AI model, right? And if you're using supervised training, it requires a labeled data set. For example, let's say you want to detect when your neighbor's dog appears in your front lawn and get an alert. You need a model that's going to just identify that dog, right? And get an alert. If a car drives by, you don't care about that, right? Some kid gets his ball, you don't care about that. You just want that dog, right? You want an alert. What you would need is you would need a training data, right? You need a training set with a lot of pictures of the dog and a label that says, this is the dog, Fido or whatever his name is. This way your model learns what Fido looks like, and when you feed images of Fido into the model with your camera footage, right, it'll be able to pop it up and say, hey, I know what Fido looks like because I saw it in my training data. But if you started to let others, you say, this works really well. You know what I'm doing? I'm going to let other people use my model, and they can upload pictures of their neighbor's dog, right, and get alerts too. It'll be great. But what if someone added pictures of your neighbor's dog, but labeled it something else other than Fido, labeled it Fifi? Your model's not going to know the difference. And if you're just looking for Fido, it's not going to alert because it says that's Fifi. That's not Fido. Just an example of a data poisoning attack. It's weaponized garbage in, garbage out, right? That's a very targeted example, but you can just add garbage. The model will spit out garbage. It doesn't have to be something this targeted or malicious, I don't know. Of course, this could work the other way by adding a different dog with the same label as the target, and that would, bring up false positives. Thank you, guys. Moving on. What if we're using a public data set? We've downloaded a public data set to train our model, or we're scraping off of Twitter, we're scraping off of Wikipedia. Not that anybody would do that. We tend to think we have this it's down here now. It's in my offshore data warehouse. No one can touch it, right? I've got this perfect, pristine data set. It captures the internet. You're assuming that there's not an army of bots, right, just pumping misinformation onto whatever it is you just scraped, specifically so AI wouldn't work that way, right? The fact is we can't control, right, what people are putting on the internet. And it's, let's be honest, if you download all of Wikipedia, how do you find misinformation on there? I mean, it's difficult, right? You would have to use AI. And then you're just, eating your own dog food. So this attack usually, there it is. This attack usually involves doing just that, right? You would need usually a lot of input in order to make the model shift a little bit, right? So this attack can be used to plant backdoors in a model. It's not a name I'm super thrilled about, but it's what they're calling it, and that's what you need to know, is that you can plant backdoors. For example, someone could poison a spam data set. If you wanted to train a model real quick on spam, you have a blank vanilla model, and you're like, I'm going to use spam detection. Download a spam data set and use it to train. That's something you can do right now, right? But, right, an attacker could poison that spam data set, right, to allow for a specially crafted phishing attack to bypass the model. You would never know that your model was compromised. It's throwing away spam like a boss, man. Nothing's getting through because it's amazing unless you know the key, unless you have the back door, the exact input to bypass the model. That's why it's called a back door. You would never notice until, whoever poisoned the data set exploited that backdoor and flooded your email network with phishing. So remember, when you're scraping data sites or scraping websites, there is a possibility that someone has poisoned that data set knowing that people are scraping it, right? It's not really hard to create, zombie bots out there to flood Twitter or whatever it is. I mean, that's basically what Twitter is now anyway. All right, so yeah, we got a few threats here. There's many, many more. But what I wanted to illustrate was just a methodical kind of approach. As Brendan said this morning, this is something we do anyway as security people. Red team or blue team or anywhere in the middle, we're thinking about what threats are posed and how we can mitigate them. The stride method, the other methods like stride, they just formalize the process. They give a nice little picture, that you can show to your organization and say we did due diligence or whatever. Let's see. Okay, yeah. The cool thing about this is that you'll come up with a list that then you can have the mitigations right next to it. So now that horrible diagram from NIST, right, you can use it, okay? Because you can pick out the mitigations from that model, the threats from that model, right, onto your threat model, and then pick the mitigations that go through them. You don't have to guess. You don't have to wonder. You don't have to Google what the latest attacks are. Right, they've generalized them. NIST is one example. MITRE Atlas, if you prefer MITRE, it's coming up. This one's just the oldest. But basically, it's a tool that you can use in threat modeling. If you try to implement the NIST AI risk management framework, God bless you. Go for it. But anyone who's read a NIST standard knows it's not that easy. It's high-level guidelines. They don't really tell you what to do, ever. They just kind of tell you how to do whatever it is you choose to do. So this is something we can actually do. We can actually download the NIST or MITRE list, and we can threat model, right, an AI model with those lists. So, like I said, real practical use. So once sorry, lost my spot. Example. Okay, so you notice I changed the names here. We don't have the fancy AI names. We change them with the stride names here. So in my example, right, we have like this information disclosure is basically a textbook for stealing data. If you're stealing data, that's information disclosure. So if we're stealing a model, right, it's pretty much a textbook information disclosure attack, or close enough at least. We have tampering threats stemming from evasion. We have data and data poisoning attacks, right? And then I'm being a little creative with the escalation of privilege from the Twitter scraping, just to highlight the utility of the backdoor threat. It's privilege that they shouldn't have had. And it's a bit of a stretch, but I want to give a different example. Okay, so that's a simple, very high-level, accurate AI threat model. We do have a Q&A at the end, but I can take up any questions on threat modeling so far?
For AI, having an output to let's say, a Florida one.
Yeah.
How do you prevent AI from hallucinating and creating a escalated privilege?
So usually when you talk about hallucinations, you're generally talking about generative AI. Predictive AI can get it wrong, but we wouldn't really call that a hallucination. So when you're talking about like GenAI, right, we do it kind of the same way that we would look at those evasion attacks, right? I'll talk a little bit about it later, but I'll introduce it now. It's a good spot. Basically, you test it by sending it input that you know what the output should be. If it changes, chances are there's been some kind of evasion attack, right? Somebody has, or a poisoning attack, I should say, right? Something in the source data has changed and you need to go look at it. Otherwise, it's really hard to detect when a hallucination occurs unless you read every output, you know what I mean? You have to have known output and then it has to be triggered. Make sense? Any other questions on threat modeling? All right. All right, we're gonna take a little break. Yeah. Yeah. All right, this is a meme. It's depicting the trolley problem. Now, the trolley problem goes like this. A trolley's heading towards a junction, and if it goes straight through, 5 people in the truck are going to die. But you, the person in this thought experiment, can pull a lever saving them. If you do, it will divert the train to a different track, saving those 5 people. Unfortunately, there's one person on the track who won't be able to escape the trolley and will die if you divert it. It's a thought experiment used in ethics. It was introduced by Philippa Foot in the 60s. It's used to discuss, among other things, AI ethics. It's really hot in like the self-driving car space. And they talk about it in these AI security classes. And so far, it's been misrepresented in every single course I've taken. It's a very simple concept. One of them didn't even get the premise right. I forgot what they said. I wish I could have remembered what they said, but they didn't even get this part right. So we're going to clear the air here. All right, first of all, there are other examples. Everybody's probably heard of them. If not, you could have 5 babies and 1 old man. You could have 2 women, 1 rich, 1 poor. It doesn't matter. You just change it to suit whatever ethics discussion you're having at the time where you need to make a choice. But in the original thought experiment, it was basically the premise was 1 man's life in exchange for 5, right? It's a thought experiment, and you can answer it any way you choose. You could dynamite the track, you could fly at the speed of light and rescue everyone because this is only happening in our minds and not in real life. You can just refuse to answer and say, well, that's a stupid question. You can, but it's not very helpful when you use it that way. This example is very helpful when you only have one choice, whether you pull the lever or whether you don't. If you do not pull the lever, 5 people die. If you pull the lever, divert the trolley, and you'll kill 1 person that would have been just chilling if you hadn't pulled that lever. That's the premise. Most people get it right, but not everybody. And before we continue, I'm going to ask, bearing in mind, there is no wrong answer, and I'm going to prove it in just a minute. If you're comfortable enough to share, who would pull the lever, saving 5 people? Raise your hand if you're a utilitarian lever puller people saver. Anybody? All right, where are my duty-bound, deontological lever levers not pulling the lever and saving the 1 person on the track? All right. About the ratio I would expect. Fair play if you didn't answer.
There's a third.
Say me.
There's a third answer.
Okay.
The guy at the lever jumps in front of the train, stopping the train.
Stop it. Just sacrifices himself? Absolutely. Fair answer. Save them all. All right. Still 1 man's life in exchange for 5, but it's your own. Okay.
But it's a choice.
Yeah, absolutely. Exercising agency, right? These people on the track don't have agency. They don't have a choice. You do. Okay. All right, now listen. In the AI classes, when they teach that AI should not be taught to pull the lever, okay? Should. Wow, I wrote that down wrong. I didn't. It should be taught to pull the lever. You should save the 5 people every time. You should kill the 1 person every time, all right? And it's a terrible idea. It's not a terrible idea to pull the lever. It's a terrible idea to learn that rote, to say always pull this lever. And I'm going to show you why. Counter example, you're not a train lever guy, right? You're a surgeon. A patient comes in with appendicitis. He's on the operating table. Now, other than his appendix, right, this person is perfectly healthy. They're about to start grad school, right? They got engaged to their high school sweetheart. They bought NVIDIA stock, right? Things are looking great. But you know that you have 5 patients that need organs that this 1 healthy patient can provide, right? You could just, take that person's organs, right, and give them to the 5 people. You could save 5 people by killing 1. And I'll even make it easy. I'll just give you a lever, pull the lever, and 1 person dies, and 5 people are saved, right? So now who's pulling the lever, right? Who's pulling the lever now and killing a healthy young person to save 5 people, right? The point of the story is that philosophy is fun, all right? Ethics is fun, but it's hard, right? And an AI security class is not the place to learn ethics, right? You don't have to correct anybody, but just blah, 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 when they start talking about AI or ethics in general in an AI security class. And that's the reason we still talk about the trolley problem 80 years after it was introduced, and we'll be talking about it for a long time more. I don't know if y'all ever saw it, but y'all ever see that trolley problem website where it was being used, I believe, to train self-driving cars, or at least an AI model. I don't think it ever made it into one. I think that was the point. But they would just keep giving you these more confusing trolley problems, right? Switching up who was on the track, right? Just trying to learn how an AI model should react based on the opinions of most people who decided to go on their website and enter anything they wanted, whether they believed it or not, right, into the training data. It's a terrible idea, but all right, thanks for the break. That was fun. We're going to talk about how we can defend AI models now. All right, we're going to talk about the practical, oh, what does that say? 10 minutes, wow. We're going to talk about the practical implications, right, of the threats that we identified in our tools. For GenAI, we rely on input validation and sanitization, right, a lot for our testing, right? For LLMs, we're basically, we engineer a prompt that tells the model, hey, this is how you're supposed to behave, and then we try to break it with those adversarial examples. You don't have to, you should learn how to do this if you're in the biz, but you don't have to, right? If you have other things to worry about and somebody wants to throw up an LLM, you can download, right, community-made prompt attacks. One's called Dan. It's called Do Anything Now. I used it years ago. I think it's still updated, but I'm not sure. But there are prompts that are just ready-made. Just copy and paste it, right, and see if it breaks. For discriminative AI, right, there are other tools. I use the Adversarial Robustness Toolkit by IBM. I think it's publicly maintained now. I think it used to be called IBM ART, but it might just be called ART now. And that will have just boom, 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 every example, right, of adversarial attacks that are in the library. There are other libraries and other tools out there. One is called a toolbox instead of toolkit is more the open source one. But you can download these right now. The code's publicly available. There's good documentation on how you can run these in labs and things like that to learn how to attack and defend against different models. And the models are listed there so you know exactly which one to use for your use case. BCDR is perhaps the most important because it's hard to patch a model. And feature analysis, right? Feature analysis, it gives hints, right, as to why an AI is making a certain decision. The reason it's important for security is that if you run feature analysis on a model and there are features it's not using, like, I don't know, hair color for a dog, I don't know, man, right? If there's a feature it's not using, get rid of it. Don't leave it in the model. Every feature you use is a potential attack vector for an evasion attack. It's like leaving services running on a Linux server that you don't need. You turn them off, right? Same thing with AI features. You always want to ask as a security professional for a feature analysis and a model card. Saying BCDR, business continuity and disaster recovery. You want to make a backup of the model is what I'm trying to say there, right? You want to have a working backup. So if that model drift starts happening, I mean, what do? There's, like I said, it's really hard to patch a model. I don't know how to do that. You have to patch the training data, right? So just have a working backup, and then you can kind of figure out how to fix it without staying down. Sorry? Fine-tuning? It could be. It could be very well be fine-tuning, especially for those back doors. Those are done in the weights, right, of the model itself, which is why, how are you going to get rid of a weight? You're going to, yeah, so fine-tuning can be of assistance there. Poisoning is tricky, but can be detected using feature analysis and drift monitoring. Same thing we talked about, just looking at the input and watching the output. That's how you know if it changes that you've got a problem in your data. Model extraction, right? Like I said, it's coming from an attacker querying your model like a lot, right? So you need to rate limit how fast people can query your model. You need to monitor the inputs and the outputs. Even if you can't look at them all, it can help with forensics later or root cause analysis. Never return a confidence score. This thing says how accurate it is. Never return that. That is great information to give someone who's trying to steal your model, right? If you can avoid that, turn it off. The only time you should ever need that is when you're developing the model. Once it's in prod, you turn it off. All right, you also might think that your Fido model is safe because who would want to steal a model that just says what your dog is, but you need to know about transfer learning. That means a model that is good at identifying one thing is good at identifying another one. All I got to do is, once I've stolen your model, give it new training data. And I can use your innocent dog finding model in order to find a certain person. I can use it to find a certain vehicle. I can use it to find an enemy tank, right? It can be used in ways you didn't want it to be used, you didn't intend it to use, and as well as creating those adversarial examples. All right, we are going to wrap it up very quickly. First, we talked about how to diagram a threat model. If you get stuck, focus on the flow of data, who's requesting and who's answering. We have a list of threats we can use. There's one from NIST. OWASP has a top 10. MITRE Atlas has some as well. And of course, this is in addition to the threat model you have to do for the underlying architecture. I'm going to skip one. And that's it. All right. Thanks so much for your attention. We do have maybe 5 minutes for questions. Yeah, 5 minutes for questions. This is really my wife's dog, and her name is Shasta, the dog, not my wife. Shasta like an inherent vice. Yo.
Out of curiosity, why is it called evasion when it seems like it's an injection? Like everyone's used traditional technology.
I do not know the answer to that, but I do know that one thing I didn't mention is that you're targeting its robustness, and maybe they thought evasion sounded better than an injection, but it almost always, I think all the example I've seen are basically an injection attack, right? If it's image recognition, you're basically fuzzing pictures and then sending them to the model. You could still call it injection. I don't know. You know why? Because they were AI nerds, not security nerds. That's why. They don't know. It took NIST to come tell them, look, that's called injection, okay, buddy? Yeah, good question. I don't know. Anybody else? Yeah.
Talk about the AI models that write code,
Mm-hmm.
how to make sure that when they write that code, it's not, you ask the AI to write a simple script, but it returns something malicious,
Mm-hmm.
no matter what the guardrails.
Mm-hmm.
How can you detect if that's true?
I don't think you can, I don't know of a way to shift that left. That has to come out in like your regular SAST and DAST, I think. I think once you find it, then you know, right? If your SAST and DAST pops up, then you know you've got a problem with the model and you need to go back and look at it. Or, you know, of course, that same monitoring, that same drift monitoring. Other than that, it's just kind of like with hallucinations, especially in a big shop where you're cranking out code, you can't look at every line, so you just need to reinforce it later on down the pipe. Just one day you'll be able to shift it left, I'm sure, but I don't know how right now. Good question. I tell you what, man, a lot of answers is what we're going to do about it. That's what I covered a couple of years ago, or we have no idea. Right? That's why we haven't fixed prompt injection attacks either. We don't know. We're working on it. We have one model that can help another model. Now we have two vulnerable models. That's been my favorite. My favorite so far. We'll use AI to check AI. Oh, that was a good idea. Automation. Exactly. Yeah, and we're taking the human out of the loop, by the way. You'll never know the output until the New York Times prints it. You know, oh, I should look at that. All right. Anything else? No? All right. Oh.
I have a quick question. Just
Sure.
about, so there's a lot of companies that have internal AI,
Mhm.
or co-pilots.
Oh, yeah.
And so there's a lot of companies that don't want their private data to be used.
Yeah.
But are there guardrails against getting Microsoft a company using company?
That was on the slide I skipped.
Okay.
So a lot of the threat modeling I do is like vendor AI. Like, you know, Google's not going to give you the code or their model to test for how they do, you know, grammar correction or Google Photos, you know, identification and stuff. You know, you're up a creek. What we do now is attestation. We basically say, here's our requirements. Just like you would say, tell to a vendor, you need your application needs to integrate with our SSO. You say, you need to do robustness testing and you need to provide us the output. There's no certifications yet. One day, just like you have SOC certification, like AWS, you can't go in and pen test their websites. They say, look, we're SOC certified, you're good. I'm hoping one day there'll be a similar thing for AI because that problem is not going away. It's going to get worse and worse and worse. We don't have any visibility into it now. We basically just ask them to certify it, right? And if they've been through any third-party attestation, we ask for that too, especially for what they call foundational models. These are models that are doing things like facial recognition, biological scans, and things like that. You want to make sure that they work the same for everybody and they've been through that responsible AI thing because it is hard. You see all these products pulled off the market that don't work because it's really, really hard to get a non-biased data set out there. So, yeah, good question. All right, I think I'm out of time. 1 minute? Easy one? All right. Well, thank you very... What's that? Oh, the dog? Yeah. Yeah, she's a sweetie. She's at home wondering where Mama is right now. Thank you very much, everyone. Appreciate it. Enjoy the rest of the time at B-Sides.